Okay, we're looking at word problems from graphing in standard form. So really quickly, a reminder or maybe instruction is that standard form is not y equals mx plus b. That's slope-intercept form. So standard form is ax plus by equals c, where a is going to be a number of something we don't know, which is why there's an x. B is going to be a number of something we don't know, which is why it's y, but these are two different things. It might be number of hot dogs sold and number of hamburgers sold equals the total number of amount of money you made or something. So c is also going to be a number. So standard form is when you're adding two different things that need its own variable each. So let's look at number one. You're helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Right away, I think that's going to be my total. So that's probably going to be the C value, but let's read on. Tables come in two different sizes, two sizes. That's why we need an X to represent one of them and a Y for the other one, because they're both tables, but they're different types of tables, different sizes. So small tables, oops, can't see this, can you? Small tables seat 4 people and large tables seat 6 people. So right away, I see three numbers. I see 180, 4, and 6, and I know that up here in standard form, I need a number to represent A, a number to represent B, and a number to represent C. So this should be pretty easy to write an equation modeling that situation. They're going to be the two different sizes of tables, and they equal the total number of seated people. So small tables seat 4. I'm going to make this my X value. So I'm going to put 4x. So when I solve it and I get an answer for x, that's for the small tables. That's for the ones that seat 4. Okay, my large tables that seat 6, I'm going to make my y. So plus 6y. And it equals the total number of people that could be seated, which is 180. All right, there's your equation. Next, it wants us to find the intercepts, and I really want you to understand what the intercepts of a graph mean. The intercepts, obviously you've learned that the y-intercept is where it hits the y-axis. The x-intercept would be where it hits the x-axis. And the reason this is important is because in standard form, it can't go past one or the other. Like you can't go past the 180 people. It's just not going to be possible. So it's going to be a graph that stops. So the x-intercept, let's think about that. I think actually, I wonder if it might be easier to graph the equation first. So let's graph the equation. We know that, actually no, it's going to be easier to find the x-intercepts first. What I want you to do is pretend that y is 0. So we're going to make a mini table, and we're going to make x 0. So if you plug in 0 for x, let's do the math. What is 4 times 0? By the way, I made a little mini table of x and y over here. If x is 0, 4 times 0 is 0. So basically that entire variable is gone. And it's going to leave us, let's say nobody sits at the small tables, 0 people. So the most we can sit with having 6 per y equals 180 means we're going to divide both sides by 6. So when x is 0, 180 divided by 6 is 30. So if nobody sits at the small tables, 30 people we could have 30 tables at 6 people each. So 0, 30 is a possibility. That's one of the possible solutions. So I'm going to go ahead and graph it. When x is 0, y is up at 30, and we didn't actually number these. So let's maybe, I hope this works out, I didn't plan this ahead. Let's maybe count by tens. So 10, 20, 30. So 30 people is one possibility. When it says give 3 possible combinations, one is 0 on the little tables and 30 big tables. So 0, 30 is one possibility. So 0, 30. So 0 at small, I should have put small. Small tables, large tables. One possibility is nobody sits at the small ones. We have 30 large tables with 6 people each. Okay. Now let's find the, actually I wrote that 0, 30 here. That's the y-intercept is 30. So let's make a table where now 0 is the y. So, and then I'll have to make a space for the x-intercept. So if 0, so let me start over. Let's go back up to our equation. If nobody sits at the large tables, if we plugged in a 0 for y, nobody sits here. Y is 0. 0 times 6 is 0, so those would cancel each other out, and you'd only be left with, I know you can't see it. Here, let me just cover it up with my pen. There we go. We'd be left with 4x equals 180. So divide both sides by 4, so 180 divided by 4 is 45. So 45 is another possibility. If we could have 45 small tables, 0 large, that would be exact. So 45, 0, if we're counting by tens, I should have probably counted by fives. But let's stick with what we already started. 10, 20, 30, 45. 45. So another possible combination is 45 small tables and 0 large. That would also seat our total of 180 people. So this would seat 180, this would also seat 180, and you know there's going to be some dots in between, but we can't go past, so I'm not drawing an arrow. I'm not drawing a line with an arrow on each end because you can't go into negative on either section because there's only going to be this many tables to this many tables or somewhere in between. So here's what I would do next. In order to find it, I'd just pick an easy number that we can plug in, like maybe 5. I mean, honestly, it's up to you. Maybe 10 itself. Since we're counting by tens, let's go with 10. Let's say x is 10. Okay, so let's go in and plug in x representing 10 tables. Let's say we have 10 small tables. 10 times 4 is 40. So I'm going to work this out over here. 40 plus 6y equals 180. So if we have 40 plus 6y, I would subtract 40 from both sides. I would have 6y equals 140. I would divide both sides by 6. And that is not a possible solution because you can't have 23 and a partial amount of people or tables. So even though I chose 10, that is not a possibility. And I actually am glad this happened because you can't have a partial amount. So for that reason, I'm not going to connect my line. It's not going to be a continuous line. These are going to be individual dots because you can either have this amount of people, or somewhere in between, but you can't have a partial person or a partial table. So 10 did not work. So we're going to try, let's try 8. And again, these are just numbers that you can come up with. We just need 3 possible combinations, and we've already got 2. So let's try to plug in a number in between those 2. So I'm just going to go with 8. 4 times 8 is 32. So let's try this equation. Do I have room over here? 32 plus 6y equals 180. If I subtract 32 on both sides, it leaves us with 180 minus 32, which is 148. And I'm crossing my fingers that when I divide by 6, it comes out evenly, but it might not. Some of these are really guess and check, and you just have to try like that. So that is not going to be one of the numbers either. So we have our 2. I'm going to go ahead and leave the third one up to you, but I want you to pause the video and actually find a number that works so that you can plot it. And you know it's going to be somewhere in between this diagonal where these 2 would connect. So try maybe 20. Or, in fact, I probably gave you a hint, but that's okay. Try a number, and wherever it is, go ahead and graph it on this line, but do not connect the line because that would imply that you could have partial in-between amounts, and you cannot. Okay, the domain and range. The domain is all of the possible x values, and so x can be only in between 0 and, let's see how far we went, to 45. You can't have negative amounts on the x-axis, and you can't have more than 45 because that would put us past our 180 people. So the domain, I'm going to abbreviate it with the domain. The domain is going to be numbers from 0 to 45, and it could exactly equal 45 or it could exactly equal 0. So we're going to put x in between. So the domain are values between 0, so greater than 0, but less than or equal to 45. So that's what this means. It means the domain is somewhere between 0 and 45. For the range, we're talking about the y-axis, and we know we can't go bigger than 30 because more than 30 on the y on the large tables would be more than 180 people, and that's how many it can have. And you can't have a negative amount. So we are between 0 and 30 on the y-axis. So our range is between 0 and 30. So again, I use the y because the range is the y-axis and the domain is the x values, the x-axis. Okay, and what do the intercepts mean? Again, these were the two intercepts we came up with, and it means that when there are 0 small tables, you would need 30 large, and when there are 0 large tables, you would need 45 small. So when there are 0 large tables, like this is one possibility, you'd need 0 large tables would be, okay, 0 large tables would be 30. Just kidding. 45 small. And when you have 0 small tables, if I'm writing too fast, you guys can go back. You'd need 30 large. Okay, so that's why intercepts are important. We know the range now that we need between either the most we can use that are large or the most that we can use that are small, or somewhere in between. So find at least one more of those that works. Let's go to the next page. This one is you are making and selling decorative bows. So you sell small bows for $3, large bows for $5. You want to earn 60 per week. So there's your three numbers. Write an equation modeling. So $3 for X, which I'm going to call the large bows. $5, oh, that's the small, sorry. $5 for the small, so I'm going to put plus 5Y to be able to equal at least $60 per week. You want to earn 60, so equal to 60, exactly 60. All right, find the intercept. So here we go. We're going to make X value at 0. So when X is 0, that means I'm going to plug in 0. 0 times 3 is 0, so those go away. You can do a little cover up trick here where you can just cover up if it's gone, because 0 times anything is 0, so it's gone. 5 times what is 60? So 60 divided by 5 is 12. So 0, 12. Let's go ahead and find when y is 0. So if we have 0 of the large bows sold, 0 times 5, we wouldn't have any of those. So we're going to cover up those. And that leaves 3 times how many of the small bows would we need to equal $60. So 60 divided by 3 is 20. So the most amount of small bows would be 20. The most amount of large bows would be 12, or we could have anywhere in between. So the X, so let's go ahead and graph these. 0, 12. Ooh, I'm not going to be able to go up to 20. Let's count by 2s this time. 2, 4, 6, 8, 10, 12. Okay, and then let's count by 2s going over 2. So to 20, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So this is, I'm also not going to connect them because I wouldn't have a partial bow. You're not going to sell somewhere in between amount of bows. You are going to have dots in between, but you're not going to connect it with a line, and you're not going to have arrows on each end because you're not going to have negative amounts of bows. So we have 2 possible combinations. If you sell 0 small, you would need to sell 12 large. If you sell 0 large, you would need to have 20 small. And then we need to find somewhere in between. And once again, I really want you to come up with one on your own, but I'll do an example to make sure you know how to do it on your own. Let's say 6. Let's say I sold 6 small bows. How many large ones would I need? So if I sold 6 small bows are the X, 6 times 3 is 18. So I would have 18 plus 5y equals 60. I would subtract 18 from both sides. I would have 5y equals, what is that, 42? And that's not going to come out evenly. So divide both sides by 5. So again, I want you to keep trying. You may have to do a little bit of a guess and check, but once you get one that works, go ahead and plot it. And again, do not connect it. That'll just be your third possibility of an amount of bows that you could sell to make exactly $60. Okay, the domain and range again. Domain is x is between a certain amount, and let's look at the x-axis to check and see. You can't sell a negative, and so it's between 0 and 20. So you'd have to sell between 0 and 20 small bows, and the range is the y-axis, so you can't go less than 0, but you could sell anywhere from up to 12, so 0 to 12. So 0 to 12 for the range. Okay, and the intercepts, I'm not going to take time to write it out, but I really want you to understand that what the intercepts mean is if you sell 0 small bows, you would need to sell 12 large. And if you sell 0 large bows, you would need to sell 20 small in order to make that $60. All right, let's flip it over. This next one is interesting because it's a submarine and it's descending. So this one is going to be able to be connected because you can have a partial in between foot amount. Whereas back here, you can't sell a partial bow. So this one, the line will be continuous. And first of all, it is not in standard form. It's in slope-intercept form. It's in y equals mx plus b form. So in order to be in standard form, you would need to have the c term, the number, the constant, by itself, and you need the a and the b on the same side. So the first thing is, in order to find the intercepts, it really does need to be in standard form. So I didn't read the problem. Let me read the problem. A submarine designed to explore the ocean floor is at an elevation of 13,000 feet below sea level, which is why it's minus 13,000. The submarine ascends. Ascends means to go up, descends means to go down. So it's going to ascend to the surface at an average rate of 650 feet per minute. So we're actually starting below and we're ascending, which means going up, back up, at a rate of 650 feet per minute. The elevation is your E, the submarine given by this function. So the total elevation is 650 feet per, per minute. And you started it below by 13,000 feet. So let's rearrange this and just, I'm going to move the 650 to the others. Actually, I'm going to move the 13,000 and the E. So I'm going to subtract the E and move it over here, and I'm going to add the 13,000 and move it to the other side. Sorry, I ran out of room. So what this is going to do is this is going to leave us with 650T minus the E equals, and I know it's on the other side, but 13,000 feet. Okay, so we could actually have graphed it. In fact, I'm going to graph it in slope-intercept form, so I'll come back to look at this when we graph it. But in order to find the intercepts, it really is easier to have it in standard form. So remember, when we find the intercepts, we make x 0 to begin with. We're just going to look at x. We're going to make x 0 and see what y would be. So if we make x 0, sorry, this is going to be, it actually doesn't matter. This is going to be like our x. So if this is 0, we cover the whole thing up. We're left with negative e equals 13,000. So negative what equals positive 13,000? The only way to make a negative number positive is by adding another negative, because negative would be positive. So this would be a negative 13,000. All right, and then on the other one, if we made y 0, if we plugged in y would be 0, we have 13,000, sorry, my equals is missing, equals 650t. So we would need to divide both sides by 650. So 13,000 divided by 650, and that is 20. Okay, so let's go ahead. Oh, so the y, X is 0. So the y-intercept is negative 13,000. So we're going to go graph that. Sorry. There we go. We're going to go graph that. Negative 13,000. I'm going to hope that these go by, we're just going to go by 1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Negative 13,000. And then the x-intercept was 20. So we're going to just go, we're going to count differently on the x-axis. We'll count by ones. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Just kidding. We're going to count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Because we don't have enough spaces. So this one can be connected. You can go ahead and connect them because it will have in between amounts. In fact, it asks this question right here. Why do the solutions not have to be whole numbers? Because it increases per, what are you talking about? Feet. It increases per feet and in between amounts. I hope that makes sense. So it's not just all of a sudden it's here and then it pops up and immediately it's here. It ascends at a constant rate, so in between amounts. Okay, let's state the domain and range. The domain is the x-axis, so we know it's going to be somewhere between, let's look at our x-axis, 0 and 20. So 0 and 20, and this again is the domain. I forgot to put a D. The range is going to be your y-axis, so let's look. That is from 0 down to 13,000. So it's below at negative 13,000, and it goes up to as great as 0. Because once it hits the surface, the sea level, it's done. Okay, we have already kind of talked about what the intercepts mean, so I hope it makes sense. This is how low you are, and this is where you're ascending to get to the surface. So let's look at the very last one. Turn that page. You borrow $1,800 from your parents. To repay your debt, you give them $150 a month. It's kind of a lot. It's given by this function. You're negative 1,800 because that's how much you've borrowed, but you're positive 150 per t time is in months, and that's how much d dollars that you're giving. So let's find the intercepts. Again, I think it's better to find the intercepts by getting it in standard form. So I'm going to move the d over here, and I'm going to move the c term back to the other side. So I am going to add 1,800, and I'm going to subtract d from both sides so that they move to the other side. So this is going to be, I'm going to start here, 150t, and when I subtract d over to here, it's going to be minus d. And when I add 1,800, it's going to be equals positive 1,800 here. Okay, so I hope you understand how I rearranged this to get it in standard form where both of the variables are on the same side. All right, when I make my little table of x equals 0, I'm going to plug it in here. And if 0 is here, then 0 times 150 would be 0. That's gone. Negative, what would d have to be to equal positive 1,800? We did this on the other side. A negative negative equals a positive. So this is going to be negative 1,800. All right, for my y-intercept, actually that is the y-intercept, negative 1,800. For my y-intercept, for my x-intercept, you have to make y 0. So when y is 0, there's no such thing as negative 0. So this whole thing is just gone. And you're left with 150 times what equals 1,800. So in your calculator, 1,800 divided by 150 is 12. So in 12 months, that will be completely paid back. So the x-intercept is going to be 12. All right, x-intercept is 12. We can definitely count by ones. 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that works. So this is your months. Probably should have been labeling the axes earlier. And then the y-intercept, you are negative $1,800. You are in the hole 18. I don't know if this even goes down 18. 1, 2, 3, 4, 5, 6. In fact, you know what? Let's do 150 because it'll count by 150s. So 153, 6, 9, 12, 15, 18. So we're going to go at 150s going down, negative 150s. Okay, so your y-intercept is negative 1,800 and your x-intercept is positive 12. So this can be connected if you want. This is actually a questionable thing. In fact, this whole question right here I think is debatable. Do the numbers need to be whole numbers? If you're paying your parent back at an exact amount on the date each month, then yes, they probably need to be individual dots representing the amount that you pay them on the first day of each new month. But it didn't really say that. Maybe you actually do give them a little bit of change each day. So I could see it also be connected to have in-between amounts. So that is kind of debatable. The domain and range, the domain is the x value. So that is going to be anywhere from 0 to 12 months. And the range is the y value. So that's anywhere from 0 to negative 18. Sorry, we'll put the negative first. So negative 1,800 all the way up to 0 when you're paid off, when you have no more debt. And again, what that means is you're going to start at negative $1,800. That's what the intercept of the y-axis is. And then you're slowly going to rise. And the x-axis, the x-intercept tells you how many months you will be able to pay them back at that rate of $150 per month.